Hi students, in this lecture we are going to discuss standing waves, also known as stationary waves. Earlier we have discussed superposition of two waves traveling in the same direction, having same frequency. Now it is superposition of two waves traveling in opposite directions, having same frequency and same amplitude. So we are taking here one special case. So we are taking two waves of same frequency. One is traveling along positive x, other is traveling along negative x. So direction of propagations are opposite and both have same amplitude. We are taking same amplitude, directions opposite and same frequency. So when these two waves superimpose, so we get one pattern and that pattern is known as standing waves. Okay, I will write here once. Let us see. So we have taken y1 equal to y1 equal to, it is a sine omega t minus kx. One is propagating along positive x and second one a sine omega t plus kx. Second one is propagating along negative x-axis. When these two superimpose, see what we get. y1 plus y2. Y equal to y1 plus y2. That is equal to, it is just like sine A plus sine B, right? It is now 2A sine of sum of those two by 2. That is omega t, right? Sum of those two by 2. Next cos difference of those two. That is now cos kx, right? That is now cos kx. Now see carefully here. This is of the form. This is of the form 2A cos kx into sine omega t. In the place of amplitude, we have now 2A cos kx. So this is what we call standing waves. In this, amplitude of each point is not same. So we can see that here. If x value 0, this value becomes 2A. If x value is 0, this value becomes 2A. If kx value is 90, this value becomes 0. That means amplitude for that point is 0. So here different points having different amplitudes. I am repeating. When we have discussed traveling waves, each and every point having same amplitude. But coming to here, from point to point amplitude changes. So which depends on the location of the point. So I will write here. So amplitude is now 2A cos kx, taking the modulus value. Okay. Now see, if cos kx equal to 0, that implies displacement is always 0, right? If cos kx is 0, displacement is always 0, irrespective of time. You can see carefully here. Once cos kx 0, whatever may be the value of sine omega t, y is always 0. That means those points are not oscillating. They are permanently at rest. And those points are known as nodes. Let us see here cos kx equal to 0. That implies the value of kx must be the value of kx must be what we can say here 90 or 3 pi by 2, 5 pi by 2 and so on, right? So what I can do here kx equal to 2n minus 1 into pi by 2. Then see what we can write here in the place of k 2 pi by lambda into x that is equal to 2n minus 1 into pi by 2. So pi gets cancelled. From this see what we get x value is 2n minus 1 into lambda by 4. Let us take n value 1. N value is 1, x value lambda by 4, right? If n value is 2, say lambda by 4, next one, n value 2, 3 lambda by 4, n value 3, 3 means 2 into 3, 6, 6 minus 1, 5. So 5 lambda by 4, next one lambda 4, it is 7 lambda by 4 and so on. So these points which are permanently at rest known as nodes. Okay. We can see here first node is at lambda by 4 x value. Second one is at x equal to 3 lambda by 4. So between successive nodes, if you see separation, lambda by 4 and 3 lambda by 4, separation is lambda by 2. 3 lambda by 4 and 5 lambda by 4, separation is again lambda by 2. 5 lambda by 4 and 7 lambda by 4, again separation is lambda by 2. That means between successive nodes, separation is equal to lambda by 2. Okay. So nodes means which are permanently at rest. Right. Now see the next case. If cos kx is maximum, or let us take modulus value here, because amplitude is always positive value, means non-zero. So non-negative value. See for which values of kx, mod kx becomes maximum. I am writing here. Let us take different color. Yeah. Right. Let us take cos kx equal to modulus of cos kx. Modulus of cos kx equal to 1 maximum value. That implies cos kx. That implies kx should be kx value. We can take 0, pi, 2 pi, 3 pi, 4 pi, and so on. So it is now n pi, right? Because we are taking mod kx, right? Now substitute values there. In the place of k, 2 pi by lambda into x equal to n into pi. So pi gets cancelled. That implies x equal to n lambda by 2. So take n value 0, x value 0, n value 1, lambda by 2, n value 2, lambda, n value 3, 3 lambda by 2, and so on. And see carefully where it is maximum amplitude. Those points are known as antinodes. I am repeating. The values of x for which modulus of cos is maximum. That means for those points, amplitude is greatest. and those are known as antinodes. We can see here first antinode is at x equal to 0. Second one is at x equal to lambda by 2. Next one lambda. So first and second separation equal to lambda by 2. Second and third again separation is lambda by 2. Third and fourth antinode again lambda by 2. That means between two successive antinodes separation equal to lambda by 2. And we got same conclusion for nodes, right? Between successive nodes separation equal to lambda by 2. That means I will write here by taking different color. That means first x equal to 0, it is antinode. Next one x is lambda by 4, node. Lambda by 2, antinode. Next again node. Next again antinode. So here you can see between antinode and node separation is lambda by 4. I am repeating. Between antinode and immediate node separation is lambda by 4. Antinode and antinode, that is lambda by 2. Node and node, it is lambda by 2. Okay. Right. You can take these notes here. Right. See points once here I have written. So we have taken equations here. Y1 plus Y2. Here cos 2a cos kx is amplitude of the particle. Okay. In fact, here you have to consider modulus value because amplitude can never be negative. Okay. So we take modulus of cos kx. Then the next one. Right. Antinodes. The positions where amplitude is the greatest are known as antinodes. Means cos kx is, means mod cos kx is 1, right? Next, nodes. The positions where particles are permanently at rest, known as nodes. Means cos kx value 0, right? Next, the distance between two successive nodes or antinodes is lambda by 2. The distance between a node and an immediate antinode is lambda by 4, right? That is the next points what we are discussing here. Let us make a diagram. Right. So I'm making a string. This is now string. What happens here is shape of the string changes continuously, and how that appears is it is like loops. Loop 1, loop 2, or wait, I will make here little bit colorful here. Take different color. Right. This is now like this. Okay, like this, we can take number of loops. I have taken here only 2 loops. Or we can take here like this. Okay. And next one. So this is how string appears for us. It looks like loops. And why it is like loops means now string is vibrating very fast, and such a fast varying The shapes we cannot see very clearly because for human beings, anything that happens within a time gap of 1/16th second, we cannot see them separately. Right? This is what we call persistence of vision. So generally it is around 1/16th of a second. So anything that happens within 1/16th of a second, we cannot see them separately. They will be overlapped. So here what exactly happens is at one instant string shape was straight line. See carefully, at one instant string shape straight line. Next instant what happens is we can see here green color in the first part, particles moving up, all particles moving up. I am showing here all particles moving up in first loop or as a whole. Second loop all are moving down, all are moving down. And third loop all are moving up. Fourth loop all are moving down. Fifth loop all are moving up. Next one all are moving down. So at this instant shape must be that is now green color. Okay, this is the shape of the string, green color at this instant. That means I can say when t equal to 0, string shape straight line. When t equal to t by 4, string shape is like this, green color. String shape is like this, green color. When t equal to t by 2, again string shape straight line. When t equal to 3t by 4, 3t by 4, string shape will be, it is yellow color. It is yellow color like this, right? And when t equal to t, again string is a straight line. So see carefully here. When t equal to 0, string was a straight line like this. When t equal to t by 4, all particles reaching their extreme positions. I am repeating. When t equal to t by 4, they complete 1/4 oscillation. That means all particles reaching their extreme positions. In first loop, all are moving to upper extreme. Second loop, all are reaching their lower extreme. Third loop, moving up. Fourth loop, moving down. Therefore, shape will be now like this. Up, down, up like this. When t equal to t by 2, all particles are completing half oscillation. Therefore, all this will come to mean position. Therefore, string is once again straight line. And when t equal to 3t by 4, now they are completing 3/4 oscillation. That means they move to, in first loop, they move to lower extreme. Second loop, they move to positive extreme. Third loop, they are moving to lower extreme like this. So shape of string is now, it is yellow line. And when t equal to t, all are coming to mean position. That means it is a straight line, right? So this is what happening, changing continuously, straight line, curve, straight line, curve, straight line. And these are happening very fast. And these are fast varying things our eyes cannot detect clearly. That's why that appears to be just like loops. It appears just like loops. And in this, if you observe, first loop, I'm showing here with a different color. I will take here, let us take here blue color. Yes, now see So these points which I'm marking here with the blue color, those are those are known as nodes. Those are known as nodes. Okay. Energy is confined to between these nodes only. See carefully. Nodes are those points which are permanently at rest. That means energy confined to between those nodes only. So in this, energy is not propagating. Energy is not propagating. That's why name is given standing waves. That's why name is given standing waves. Energy confined to only those loops. Okay, converting into kinetic energy, converting into potential energy. Like this keep on changes between kinetic and potential. But energy does not cross nodes. Okay, right. Now see carefully here some important points. All points having same time period. First condition here. All points having same time period. That means all complete one oscillation same time. All are moving together. Okay. Next, different points having different amplitudes. Even though same time period, but different points having different amplitudes. And we can see midpoint of nodes, that is called antinode. Midpoint of nodes, that is called antinode, having maximum amplitude. Okay. Midpoint of these nodes is known as antinode. Okay. Right. And if you see carefully, in first loop, if particles moving up, in second loop they are moving down. That means the particles in successive loops are out of phase. I am repeating, particles in successive loops are out of phase. If in first loop they are moving up, in second loop they are moving down. In third loop they are again moving up. That means if you take alternate loops, I am repeating, if we take alternate loops like 1, 3, 5, 7, those particles are in phase. Or if you take 2, 4, 6, 8 like this, they are in phase. But if you take successive loops, they are out of phase. So phase difference equal to 180, right? And you can see here between successive nodes, separation equal to lambda by 2, right? Now see one the nodes for this one. Right, all points between two nodes are in phase and all points vibrate with the same time period but with the different amplitudes. See next one. Let us take here one special case where both ends of the string are fixed. We are taking here one special case where both ends of the string are fixed. Okay. Let us take string length is L. One end is x equal to 0 and other end is x equal to L and both are fixed. Therefore, these two are nodes. Okay, I am writing here, taking both ends fixed. I will draw a diagram for that. So we are taking a string. Both ends are fixed. This is x equal to 0 and this is x equal to L, right? So here one possibility, if you plug at the midpoint, we get a shape like this. String shape becomes like this. After some time becomes a straight line. Next becomes like this. And once again becomes straight line. So keep on changes. That means it is now only one loop. When there is only one loop, I am taking here n equal to 1. When there is only one loop, it is called fundamental frequency. It is known as a fundamental frequency, where n equal to 1 means there is only one loop. And in this one loop means these two corresponds to node. Between successive nodes, separation equal to, it is lambda by 2. That means we can write L equal to lambda by 2. So if you have only one loop, that is called fundamental mode or first harmonic. Fundamental mode or first harmonic. Suppose having Suppose having two loops. Two loops means like this. At one instant, shape is like this. Next becomes a straight line. Next becomes dotted line. And next again becomes a straight line. So this will repeat. So it appears just like loops. When we have two loops, that means n equal to 2, n equal to 2. This is known as second harmonic. Second harmonic, or it is known as first overtone. It is known as a first overtone. Okay. And see here length is L. That L equal to lambda by 2 plus lambda by 2. It is 2 into lambda by 2. Right. Suppose if you take three loops. Three loops. One, two, three. Right. Next one I'm showing dotted. So initially straight line, next solid line, next becomes a straight line, and once again becomes it is dotted line, and finally straight line. Now this will repeat. So here number of loops 3, n equal to 3. It is known as third harmonic. Known as third harmonic, or it is known as a second overtone. It is known as second overtone. Again, we can write length equal to 3 into lambda by 2. Right? If you generalize, if you have n loops, then L equal to n into lambda by 2. That implies lambda equal to 2L by n. Right? Right. So in case of a stretched string, speed of a transverse wave, that is known root of t by mu. So if you want to find frequency, so right here frequency f equal to, we are writing v equal to f lambda. So f equal to v by lambda, right? So in the place of lambda writing 2L by n, so it becomes n by 2L. In the place of v, root of t by mu. This is now expression for frequency of nth harmonic. Nth harmonic means there are n loops. Okay? There are n loops. And see one more thing here. When there is only one loop, there is only one antinode. When there are two loops, there are two antinodes. When there are three loops, three antinodes. That means if number of loops are n, then number of antinodes also same. Okay. Number of nodes equal to number of antinodes. Right. And if you are taking nodes, for one loop, two nodes. For two loops, three nodes, 1, 2, 3. For 3 loops, 1, 2, 3, 4, that means n plus 1 nodes. N plus 1 nodes. Right? Okay, suppose the question is second harmonic. Second harmonic means n is 2. So 2 antinodes. 2 plus 1, 3 nodes. Right? Are given first overtone. First overtone means second harmonic. Nth overtone it means n plus 1th harmonic. Right? So this is now expression for frequency of nth harmonic. Right? And see notes for this one. And here one more thing, writing the wave equation. Writing wave equation. See carefully how to write, which is very important, writing wave equation. So how to write wave equation? Right. So given that x equal to 0 and x equal to L, they are fixed. That means x equal to 0 must be a node. Therefore, we have to write it must be sine function for cos kx. Sine kx. So kx must be sine function because x is 0, sine is 0, right? So it must be sine. Suppose amplitude is 2a. 2a sine kx. Next one, is it sine omega t or cos omega t? How to decide that? Okay. Let us take, I am taking here only one loop. I am taking only one loop here. That means midpoint corresponds to antinode. Okay. Suppose question is given like string shape is a straight line when t equal to 0. What is it? String shape is a straight line when t equal to 0. Number of loops n equal to 1. So what is now equation for this standing wave? Take amplitude is 2a. So taking string length along x-axis and oscillations along y-axis, right? Then say how we are writing y equal to 2a sin kx. Y sin kx means x equal to 0 is now node. So x is 0 means sin kx is 0, right? Coming to omega t. When t equal to 0 at antinode, the point corresponding to antinode is at mean position. That means t equal to 0, displacement must be 0. And that happens when we are taking here sine omega t. Okay. This is equation for this one. Okay. Suppose same you are given like this. Same conditions, one loop, but string shape is now like this. This is now string shape at antinode. That point is at its peak level, means extreme position. Then we have to write it is a 2a sin kx cos omega t, because when t equal to 0, for this point, displacement is maximum. So displacement is maximum when cos omega t is 1. That's why it should be cos omega t because t equal to 0, right? So when you are fixing x equal to 0, it must be sin kx. To decide remaining one, is it a sin omega t or cos omega t, then focus at antinode. If it is at mean position sin omega t, if it is at extreme position cos omega t. Okay, right. Now see the notes for this. Yeah, it is now 2a sin kx cos omega t or 2a sin kx sin omega t. So this depends on given conditions, right? Okay. So I have taken notes. You can take notes here. If n equal to 1, it is called fundamental mode or first harmonic. N equal to 2, it is called first overtone or second harmonic. N equal to means 2 loops, right? N equal to 3 means 3 loops. Then it is called second overtone or third harmonic. So if number of loops are n, then number of antinodes n and nodes are n plus 1, right? If number of loops are n, then length of the string is n into lambda by 2 because for one loop, separation equal to lambda by 2. This is what we have discussed, right? So from that we got lambda value to L by n. Therefore, for nth harmonic, frequency is n by 2L root of t by mu. Okay. So this is when both ends are fixed. Okay, see next one. Now both ends of the string are free. Okay. See how it is possible. Both ends of the string are free. Free means, so we can see this is where this one end is fixed. Right before that. Yeah, both ends of the string are free. Both ends are free in the sense. Connect both ends to rings like this. And these rings are passing through a smooth rod. Passing through smooth rod. So between the rings and rod, there is no friction. Therefore, these two ends are free to vibrate. So when they are free to vibrate, those points correspond to antinodes. Let us take this is x equal to 0 and x equal to L. Okay. So antinodes means the first possibility is like this. Half loop and a half loop. Okay. Because these points are corresponding to antinode. And we know antinode and node separation is lambda by 4. Node to antinode lambda by 4. So this is totally equal to lambda by 2. Right. And see next possibility. So two half loops, one complete loop like this. So in every frequency, we are having two half loops. Okay. So first one is known as a fundamental mode, and this is a fixed fundamental mode, right? And this is known as first overtone. This is known as first overtone, or it is known as third harmonic. In this, there is no second harmonic, only third harmonic. You can see why there is no second harmonic. So coming to first one, lambda by 2. So lambda by 2 is equal to L. Frequency equal to F equal to. So we know V equal to F lambda. So F equal to V by lambda. and lambda equal to 2L. So this is now V by 2L, right? Sorry, this is not third harmonic. Just a minute. Let me correct this one. This is a second harmonic, okay? Yeah, first overtone or second harmonic. Next, coming to here, lambda by 4. This also lambda by 4, lambda by 2, lambda by 2 plus lambda by 2. This is now 2 lambda by 2. So same as the previous one, no change in that. Only changes here having two half loops, first one. In the previous we got one complete loop. Here we got two half loops. Coming to in first overtone, we got two complete loops in previous one. Here we got two half loops and one complete loop. That is the only change. Remaining frequency formula same as it is. Okay. And one more thing. When we take first harmonic, number of antinodes, two antinodes and one node, right? And if you take here second harmonic, one, two, three antinodes and two nodes. That means here nth harmonic nodes, number of nodes are n. Check once. First one node. Second one, two nodes, right? Nth harmonic, n nodes. And coming to antinodes, n plus 1. If you see first one, we have two antinodes. Second one, three antinodes, right? See nodes for this. So fundamental mode or first harmonic, only two half loops, first overtone or second harmonic, one complete loop and two half loops, right? Second overtone or third harmonic, two complete loops and two half loops. That means the first overtone means one loop, second overtone, two complete loops. That means nth overtone, n complete loops and two half loops, right? And remaining formulas as it is, same as the previous one. So L equal to n lambda by 2. Therefore, lambda equal to 2L by n. Therefore, for nth harmonic frequencies, n by 2L root of t by mu, right? And coming to writing equation for standing wave. Since both ends are free, x equal to 0 corresponding to antinode x0, amplitude must be maximum. That's why it must be cos function. It should be cos omega t. Okay, cos omega t. Remaining one sin omega t or cos omega t. This depends on same as the previous one. At antinode, if it is at mean position, take sin omega t. At antinode, if that point is at extreme position, take cos omega t. So here it must be cos kx because ends are free. They are antinodes. Okay. Now see next one. One end of the string is fixed. Let us take x equal to 0 is fixed and x equal to L is a free end. And this also same as the previous one. Since x equal to 0 is fixed, we must take sin kx and remain logic as usual, same as previous two cases, sin omega t and cos omega t, right? Let us draw a diagram for this one. So one end is free, other end is fixed. Let us take this is x equal to 0 and this is x equal to L. So first harmonic means only a half loop because the fixed one corresponds to node and free end corresponds to antinode. Antinode and node separation equal to lambda by 4. So lambda by 4 is equal to L. That implies lambda equal to 4L. Now see next possibility. One complete loop and one half loop. So lambda by 2 plus lambda by 4. 3 lambda by 4. What is it? It is 3 lambda by 4 that is equal to L. That implies lambda equal to 4L by 3. Right? So if you take like this and if you observe carefully, when we calculate frequency, F equal to V by lambda. Lambda is now first one 4L, right? So V by 4L, first one. But if you observe next one, it is V by 4L by 3. 3 comes here. Next frequency is 3 times of first frequency. That's why this is known as a third harmonic. I am repeating. First one V by 4L, but next one V by 4L by 3. It is now 3 times of the first frequency. That's why this is known as third harmonic. So in this, there is no second harmonic, right? That means we can generalize now lambda equal to 4L by 2n plus 1. And here n corresponds to overtone. Okay. So here first overtone. This is a first overtone. Means a third harmonic because n equal to 1, 2 into 1 plus 1. This is 3. Okay. Third harmonic. So n corresponds to overtone. Then frequency will be F equal to V by lambda. That means it is 2n plus 1 by 4n into root of T by mu. Right? This is an expression for frequency. So in this only odd harmonics are possible. Like 1, 3, 5, 7 and so on. Okay. So first fundamental mode only half loop. Next one first overtone or third harmonic. One complete loop and one half loop. Okay. And see notes for this one. So fundamental mode or first harmonic only half loop. First overtone or third harmonic. One complete loop and a half loop. Second overtone or fifth harmonic. Two complete loops and a half loop. So we are generalizing now. Nth overtone or 2n plus 1th harmonic means n complete loops and a half loop. So L equal to 2n plus 1 into lambda by 4. So lambda equal to 4L by 2n plus 1. So for nth overtone frequencies, F equal to 2n plus 1 by 4L into root of T by mu. Okay. This is about one end is a fixed, other end is free. Right.